My dear students, again in this particular session, I will be giving you some short guaranteed 50 marks in just 10 to 12 minutes. So be with me till the end. These are some frequently asked questions and they are very easy questions which are asked almost every year in your NEET examination. First of all, a question will be asked, what are the examples of extensive properties and intensive properties? They'll give you the question, right? They'll give you 2-3 examples wherein you have to identify whether it is the extensive property or intensive property. So remember these examples: extensive properties, mass, volume, heat capacity, enthalpy, entropy, Gibbs free energy, internal energy. These are the most common examples of extensive properties. Similarly, intensive properties: temperature, density, molar heat capacity, specific heat capacity, pH, boiling point, concentration, as well as EMF of the cell. These are the examples of your intensive properties, right? Similarly, I'll add one more term here: molar entropy. Molar entropy, it is again one of the important examples of your intensive properties. Now, similarly, moving on to the second point. If entropy is kept as the criteria for spontaneity, then for the process to be spontaneous, what is the condition? If entropy is the only criteria for spontaneity, then remember, delta S total means delta S universe, it should be greater than 0, then only the process will be spontaneous. If delta S total is less than 0, process is going to be non-spontaneous. If delta S total is equal to 0, we say it's going to be reversible. Okay, this can be directly a statement-based question asked in your NEET 2026 examination. Okay, moving on to the third concept. They can give you any of these graphs and they'll ask you what is the order of the reaction. This 1, 2, 3, 4, 5. These 5 graphs are basically the graphs for the zero order reactions. Perfect. They can put any graph in the question. They'll ask you what is the order of the reaction. Remember these graphs, they are the zero order reaction graphs. And the graphs which are mentioned over here, they are the first order reaction graphs. Okay, well, I'll be sharing the PDF of this particular session on my Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel on which you'll get this particular PDF. Well, I forgot to share the earlier 2 PDFs. I'll be sharing right after this particular session, okay, in the Telegram channel. Similarly, guys, as I told you, these are the graphs which are basically valid for the first order reactions. Remember them as well. Now, question can be asked about free expansion. How do we define free expansion? Free expansion is nothing. It is expansion in vacuum. Expansion of gas in vacuum. Expansion against zero external pressure. First thing which you have to keep in mind, whenever in the question they'll mention free expansion, whenever in the question they'll mention vacuum, remember W value is taken as 0. Now, if there is isothermal free expansion of an ideal gas, since the term is free expansion, so W value is 0. The gas undergoing isothermal process, so delta U is also 0. The ideal gas undergoing isothermal process, delta U will be also 0. Now, first law of thermodynamics says that delta U is equal to Q plus W. Now, W is 0, delta U is 0. That means Q automatically becomes equal to 0, right? So this is what happens in the isothermal free expansion of an ideal gas. So they'll ask you, when the ideal gas undergoes isothermal free expansion, what all parameters can be 0? These are the parameters which can be 0 here. Similarly, adiabatic free expansion of an ideal gas. The term is free expansion. That means W value is 0. Adiabatic, Q value is 0. If W is 0, Q is 0. First law says delta U is equal to Q plus W. So delta U is 0. Now delta U itself is basically NCV delta T for the ideal gas. So this has to be 0, which means that delta T value is equal to 0. They can ask you which all parameters are 0 when the ideal gas undergoes adiabatic free expansion. So these are the parameters which will be 0 when the gas undergoes adiabatic free expansion. One more short question that can be asked. Similarly, this is one more table, my dear students. Perfect. From which question can be asked. If you will be having any process, for example, A gives B. Let's say we have got a process, A gives B. We have got a reaction, A gives B. Perfect. Now, during this reaction, if delta H is negative, delta S is positive. Delta G will automatically come out be negative, and we say the reaction is spontaneous at all temperatures. Similarly, if delta H is negative, delta H is positive, delta S is negative, right? Delta G will be always positive, which means that the reaction is going to be non-spontaneous at all temperatures. If delta H is negative, delta S is negative, delta G will be only negative, right, at low temperatures. So I would say that particular process for which delta H is negative, delta S is negative, we say that particular reaction will be spontaneous only at low temperatures. Similarly, positive. This particular reaction will be spontaneous only at high temperatures. This is again, my dear students, one more table from which a theoretical question can be asked. Okay, so remember this particular table as well. Moving on to the next one. Direct relation between molality and molarity. This is the direct result between molality and molarity. molality is equal to 1000 into molarity of the solution divided by 1000 into density of solution minus molarity into molar mass of solute. For example, this survey question will be asked. Calculate the molality of 1 molar NaOH aqueous solution whose density is given. So what you'll be doing? You'll write M is equal to 1000 multiplied by molarity is 1 divided by 1000 multiplied by density of solution is 1 minus molarity, that's 1. Molar mass of solute, that's 40. Just a matter of calculation. Solve this. This will give you molality of the solution. Remember this result. It's very, very, very important. Okay. Similarly, like this, there is one more result. A result between molality and mole fraction. Molality and mole fraction. Remember, molality is equal to 1000 mole fraction of solute 1 minus mole fraction of solute molar mass of solvent. This is a direct result which relates molality with mole fraction. Remember it directly. Now a question can be like this. Calculate molality of the aqueous solution in which mole fraction of solute is 0.2. So what you have to do? M is equal to 1000 multiplied by mole fraction of solute is 0.2 divided by 1 minus mole fraction of solute is 0.2. Molar mass of solvent, since it's aqueous, that means solvent uses water whose molar mass is 18. Just solve this, a bit of calculation, and you're done. Similarly, my dear students, they'll ask you, Lyman series falls in which range? Balmer series falls in which range? Similarly, Paschen series falls in which region? Remember, you have to remember UVIII. U means ultraviolet. U means ultraviolet. V is visible. V means visible spectrum. This means infrared. This also means infrared. This also means infrared. And you can write it as far infrared as well. Perfect. If they ask you, Paschen series falls in which region? Your answer will be infrared. Bracket series falls in which region? Infrared. Okay, or you can write far infrared as well. This is the question that is frequently asked in your NEET examination as well. Similarly, a short question that's almost asked every year. Which of the following quantum numbers is incorrect? Which of the following quantum numbers is incorrect? My dear students, N represents your principal quantum number. L is your azimuthal quantum number. M is your magnetic quantum number. S is your spin quantum number. Okay. And L can have values from 0 to n minus 1. M can have values from minus L to plus L. S can have only two values, plus 1 by 2 and minus 1 by 2. Now, for example, look at the first one. Let's check whether it's correct or not. N value is 5. So the electron is present in fifth shell. L value. L is from 0 to n minus 1. So 0 to 5 minus 1. That means 0 to 4. So it can be 0, 1, 2, 3 or 4. 4 is mentioned, correct. M. M is from minus L to plus L. M is from minus L to plus L. So minus 4 to plus 4. Minus 4 to plus 4. Right? 3 comes in between. So it's correct. S can have two values, plus 1 by 2, minus 1 by 2. This is correct. Okay. Now tell me whether this is correct or incorrect. This is incorrect. Why is that? Because L value is from 0 to n minus 1. 0 to 5 minus 1. 0 to 5 minus 1 means 0 to 4. So 0, 1, 2, 3, 4. It cannot be minus 4. So this is incorrect. Right? Similarly, M value is from, okay, look at this one. This M, this principal quantum number, that's 5. Azimuthal quantum number, that's 4. So this is correct. This is correct. Now, minus L to plus L, this also correct. Plus 1 by 2, this also correct. Now look at this one. Here you can see spin is 0. Spin cannot be 0. Spin can have only two values, plus 1 by 2, minus 1 by 2. So this is incorrect. So this is how a short question is also asked. Calculation of valence electrons. Again, one simple concept. My dear students, you will be given with the matter whose first ionization energy, second ionization energy, third and fourth will be given. We will be supposed to check how many valence electrons will be there in the atom. First ionization energy means to take the electron, to take the first electron out. To take the first electron out, 100 electron volt energy is required. To take the second electron out, 200 electron volt energy is required. To take the third electron out, 300 electron volt energy is required. Now to take the fourth electron out, 4000 electron volts are required. Do you see huge jump here? Do you see huge jump here? That means the fourth electron would be present in the penultimate shell. Right? The fourth electron will be present in the penultimate shell. Right? And closer the electron towards the nucleus, more energy is required to remove this. That's why the jump here is huge. So technically, I must say the fourth electron has to be taken from, not from the valence shell, but one shell before valence shell. That's called as penultimate shell. Perfect. So they'll ask you how many valence electrons are there. As you can see, there are 3 valence electrons. Perfect. So these were some short 11 concepts, my dear students, which are almost asked every year. And these are easy questions. You can expect 1, 2 out of these concepts in the upcoming NEET examination as well. Right? Share this video with all of them, all of the students, so that everyone gets benefited out of these videos. Take care. God bless you all and love you all. Bye-bye.